Hello, welcome to episode number 104 in this series where I am programming an NES game from scratch. I'm going to try and keep this one short because I'm coming down with a cold, and so I figure I should get some sleep, especially given that I've started this one a little bit late. Last time we were live on stream and chatting it up, and I was trying to make it so that we went from the map and transitioned to a specific repeating tile, and got some of that change happening, but not quite. So let's take a look at that. What I think is happening right now is we are subtracting from the screen memory address. Just gotta find where we are here. So we have the screen memory, and we're subtracting 32 from it because we're subtracting the number of tiles that we are trying to go past. It's 32 because it's 32 tiles across the entire screen. It's not the number of metatiles. But when we get to the bottom, we are continuing to let me rephrase that. When we get to the end of the name table, then we are continuing to subtract instead of going back to this part of the name table. So when we are at 2000 hex and we subtract 20, we get 1 FE0. And so let's see. We should check if we have E0. Compare to E0. That's going to compare A to E0. Branch not equal. All right, let me fix this because this is doing a double anonymous branch. So let's see if skip row decrement. So that's this skip row decrement. It just means we haven't rolled over to another multiple of 8. And then let's see. So we're going to compare this branch not equal to we can go to skip row decrement because we are done checking, and then if it is equal, then we want to load a screenmem +1 and compare it to 1F, and then branch not equal again to skip row decrement, and then here, let's put a comment in here, check to see if the memory address has been decremented to 1FE0, which means it needs to wrap to the this 2BA0 bottom of the next name table. Now this is just going to cover this case because we're going to get to the point where we're at 2800, and then we have to go to 23A0, and we're not going to do that properly, but let's start with this one. So if we are equal here, then we're going to load a, what did I say this value was? 2BA0, A0 stored in screenmem, and then load A to B, and store A in screen m plus 1. Because again, what we want to do is once we get past this, we need to go to here. So that should let us do that properly. Oh, you know what? That should be we want to go to that. We want to actually force it to do the new row update here. All right, let's see if that fixed that part of the logic, and then if that's looking close, then what we can then do is fix the other part. So if we refresh the game and start it off, and I shorten the level just so that it's not so much time to get to this point. So I gotta reverse. So I want to rewind and see what happened here because I missed it. All right, so it's interesting. It's not. Let's take a look at screenmem. I gotta find where that is first. So that's 86. So, all right, so that's definitely not right. It's 5B42 right now. So let's see. All right, so right now, oops. Right now this is okay because it's doing the decrement. Huh. Let's go back for a second here. I'm just rewinding the playback of the emulation here. So it's at 22.2230A08060, and then oh, is it? Am I? Huh. Let's take a look at this for a second. Do I have the memory address wrong? So 2260. Okay. Oh, so it's big endian. Why did I think it was? So, okay, so the problem is I'm reversing the order of which bytes I'm operating on, and that obviously won't work. I think it's because I'm thinking about how that would work if addressing memory in the RAM and not the PPU. All right, so that explained why we were getting such weird behavior there. Let's see if that now. Let's just bring up all these. various windows and have the scrolling restart here. All right, so T2202. The question is, why is it 02? C0A08060. Yeah, so that's screenmem. What are you? What you doing? So you're loading. Let's see, we're loading. Oh, I didn't. Okay. I didn't change this one to be the one that we're actually messing with here. So let's rebuild that. Missed one. All right. And I apologize if I'm quieter than usual, but this congestion is just, you know, you get the sinus pressure and the throat kind of gets you, and it's no fun. I don't like this, and I get this like twice a year, and it passes after a little while, but it's still aggravating. All right, so that's actually much closer to what I was expecting. So it's it looks like it's updating the tiles. Highlight tile updates. Let's rewind. This might take a little while. I'd pause the game rather than the emulator. I should remember to do that. I should remember to pause the emulator instead of the game when I want to do this kind of thing, because with pausing the game, then you have to rewind the entire amount of time that the game was paused. Here we go. Did I run out of rewind? No. Okay. Very good. So slow down the emulation. So it looks like it's doing the updates. Rewind for a second here. It looks like it's doing it a little bit behind what I was expecting. You know what? Part of it might also be the scroll speed is so fast that it's creating more of an issue. It's creating more of an issue for the updates. They're being updated as they come into view. I wonder, do I also have the overscan turned off? No, I have it turned on. What we should probably do is when we transition, let's take a look at the map. So it gets to the 0 tile there, and then it looks like it's updating that one again. Well, what we probably want to do is have it go to this next one to do the update. instead of the one that it was already on. So let's make it so that when we transition the background mode, that we also modify the screenmem position. So this is where we check to see if we need to go into the repeat scroll. We set our background tile, and then we populate the single tile into the new tiles array. But we should also, in this part here, do the subtraction for screenmem. So load a screenmem +1, right? Because we want the bytes are in sort of what you would think of as the natural order, where it's the most significant byte is the first byte, and then the least significant byte is the second byte in the set of 2 bytes. I'm just used to little endian mode, if you're familiar with endian mode from using any other assembly language like Intel x86 assembly language. There's different byte orders that can be used by CPUs, and Intel uses little endian, and so the order on the bytes is different than on big endian, where so if I get this wrong, you'll let me know in the comments, but I'm pretty sure, if I remember, in little endian mode, the most significant byte comes first in memory. So you get if it's 4 byte, let's say it's 2 bytes, it's most significant byte, least significant byte, versus big endian mode. No, sorry, I reversed that. Least significant byte and then most significant byte, versus little endian mode, where it sorry, keep reversing it. So this is little, and this is big, where it's most significant byte, least significant byte. And so when you read it, to some extent, big endian mode seems more intuitive, because it's sort of the natural order of reading when you're looking at numbers. But different CPUs handle it in a different way, depending on the way that the CPU decodes the addresses. And so, yeah, it's just a different way. Yeah, I got that right. I did a quick search on the other screen. So right now we're storing that in big endian mode here, so that's why we need that second byte first to do this subtract. So set carry and subtract 20 hex or 32 decimal. And then we want to store that in screenmem +1, and then branch if carry is set to here, and if carry is clear, then we want to decrement screenmem, because we've gone from we've borrowed from the byte here and need to decrement it. All right, so that will put it in a position where now we are not overwriting the last row from the map any longer. I'm gonna go back to normal speed. Okay, so let's see if that looks correct now. Nope. That's weird. Go back for a second here. What did this do? Why did this? I guess I didn't check the boundary, so maybe that's what happened, but that shouldn't matter. Go back. too fast. I didn't get a chance to look at the debugger. There's memory here. Two 2220 22200. Pause emulator. Was it 28? 2800 is the boundary with this. Did I go to 2260? I did go to 2260, which is wrong. Of course. All right, well, that's what I get for not checking. So should I just write a subroutine that checks screen memory and corrects it for me? Because we're going to need that up above too. So check adjust screen mem. So basically all we want to do is we want to load screen mem. Let's see. We want to check to see if we have gone from 2800 to 2760. Is that right? Wait, what? Oh yeah, I misread that. So that's actually not the issue. 2260. 2260. That's okay. So that updated, although that still is that just the bottom of the tile set that I'm looking at? It's possible. Yeah, that looks likely that that's the bottom. So it didn't. Okay, so. And then if I continue emulating, it went to 2220, but it then didn't write the right thing. So it skipped 2260. Which admittedly should have been updated with the last bit of the map. So maybe this was an unnecessary adjustment. But it's weird that then it didn't. Right, you know what? Let's let's go back. Let's not do that because it seems like that actually made the problem somewhat worse, just because it's not, it's naturally not loading the last row, I guess, because we hit the camera position 0 first. Do we want to check for like camera position FF? Can try that. So that it forces it to load that last bit. I don't know that that actually matters that much, but let's see if that will make it behave that way. Okay, cool. So that did actually force it to load that way now. So we just then hit a glitch when we got to the next part. Okay, I can live with that. So what we'll do is we will do the correction here. So, sorry, I was trying to decide if I wanted to do it and then was like, well, we should make that work properly and load the last row. So load a screenmem +1, subtract, set carry, subtract 32 decimal, store it into screenmem +1. Oh, this is why it's going weird, because I am then messing with the not setting the background mode properly. So load a screenmem +1. So then it's probably defaulting to scrolling, which is why we were getting garbage. That makes more sense. Okay, so load a screenmem +1, set the carry, subtract 20, 32 decimals, store screenmem +1, branch carry set to this anonymous label, otherwise decrement screenmem, and then jump to subroutine check screenmem, and then let's do that. Let's implement that. Check screenmem RTS. Make sure to have RTS, because if you don't, that'll be a problem. Load a screenmem. So if, let's see. So if the screen, if we go from 2800 and we subtract, we take 2800 in hex and subtract 32 decimal, which is 20 hex. That's 270. So let's see. So we want to check if it's either 27E0 or 1FE0. So, okay, this is good because we can check compare. Let's do it for screenmem +1. Compare to E0, because in both cases it's E0. Branch if not equal to this, which means that we just return. Now done checking screenmem. How about that? Let's put a scope here. And this is just going to fix the memory location if we go past the bottom of the name table location and need to roll over to the other one. Okay, so now if in either case it's E0, then we just have to see, is it 1FE0 or is it what, 27E0? Is that what I said? Yeah. So compare to 1F. Branch, if not, let's say, branch if not equal to this, and this will then jump to done checking screenmem, but it will first load A with, so 1FE0 is the bottom of the name table here, or means we've gone past that, so we want to go to the bottom of the name table here, which is 2BA0. So we're going to load A0, store that in screenmem +1, and load 2B, and screenmem, store that, and then we jump, and we're good there. Otherwise, we need the anonymous label here, and we're going to compare it to 27. And then if it's not either of those, then we just have, it just happens to be E0 in that other byte. So, but compare branch if not equal to done, checking screenmem. Otherwise, we want to load the bottom of this name table here, which starts at 2000, which is 23A0. So A0, store it into screenmem +1, load A23, store it into screenmem, and then we can just fall through into done checking screenmem. Cool. Okay, so what we're going to do now, oh good, we called that here, and then we load the repeat scroll, and we store it in the background mode, and we store our tile, and all that other good stuff. Alright, so that's that, and that will adjust the screenmem variable accordingly. Let's call that here as well. So we do our decrement, and then let's get rid of this. And this will be okay, so sorry, I'm just making sure I'm removing the right part. So jump subroutine, check screenmem. So that should be that. That should fix 1641. Yep, that is a bug, or a syntax error, rather. Check screenmem undefined, 1037. Check screenmem. It's because I put it in that scope, which means it's not. It doesn't know that it's there. Okay. Label has to be outside of scope, right? Okay. Let's reload the ROM. For those of you who have pre-ordered, should have said this at the beginning. For those of you who have pre-ordered, I apologize for not having updated the code recently in the GitLab project. I will do that soon. I was meaning to, but with everything going on, I just didn't get a chance to do it. Not that you're missing out that much right now, but I do want to try and keep that up to date as much as possible. And by this week, it'll be synced up so that you have the latest. Okay, so what happened? Jump subroutine, check screen mem, load this, but it doesn't even look like it got that far. Subtract. I'm confused. Let's watch things here as they unfold. All right, why did we not go to the right background mode? A2. We are in background mode 1, which is not repeat scroll, right? No. Why? Load a screenmem +1, subtract 20. That's fine. In this part, we were checking if the camera position was at FF, because we had reached the bottom of the screen. And then branch if not equal. Skip scroll process. Load a screenmem +1, subtract 20. Store a screenmem +1 branch carry set to that. If it's clear we need to do that, then we jump to the subroutine. Skip row process. Oh, I'm in the wrong file. Let's see this. All right, why are you not? Yeah, let's see if why we're not getting to here or here. Because that part was working fine before. It was just that I was wrong in the way I was dealing with the PPU memory. All right, so we hit that breakpoint. Camera mem, Y position. That's at 6C. What are you doing? 6C. That's 6C. Y, compare FF. Okay, yeah, I didn't want it there. I wanted it. Load A, compare. Load a camera, Y position decrements, set the carry, subtract, branch camera set. Okay, so that's not gonna go. Oh, wait a minute. I just messed up that check. That's weird though that it worked. Maybe it didn't work. Maybe I thought it had worked, but it turned out it didn't. All right, so that is in down scroll Y, load a EF. Okay. Where is it doing the compare for FFFF? Here. So it's decrementing that, and then based on, okay, so then load a camera Y position. Oh, I guess I don't need to do that twice. I can just do this. Compare, and then load a, compare, this, okay. Because it's already in A from the subtraction that we did. That was working before with the 0 because the branch was being called based on this result of the subtraction from A. Let me fix the breakpoints because they're not going to be exactly right. No, that one's okay. Okay, yeah, they're all right. Let's open up the PP viewer here. All right, so good. So we're in that position. Screenmem is, where is that located again? 86. 2240. Okay. so it's gonna step through and subtract 20 from that. Oh, sorry, 32, 20 hex branch carry set. It wasn't. It was set. It wasn't cleared by the subtraction, which is fine. It checks the memory. It's okay. Now it's actually setting the background scroll. So let's see. All right. So there's still some weirdness. I don't know what that flicker was all about. Let's take a look at this again. All right, so okay, so that is wrong. It should not be doing 1E anything. So my check screenmem is not working. Load a screenmem +1 compare to E0. It's probably just some sort of dumb logic bug in the way that I wrote this. Alright, so... But that explains the flicker. It's because the way that it's updating the memory, it's going into regions of the PPU RAM it should not be updating, and that's why it's causing odd behavior there. So let's see what it's evaluating. Okay, so screenmem is 21E0. 21E0. That's okay, right? Because that's fine. So it should just be the 1F E0 or so compare it to 1F. Oh, do I not? I never load the first byte in. Oh man. So I checked the least significant byte, but then I did not load the most significant byte, which would explain why it is doing dumb things. And I'd like to think that these kinds of mistakes are just purely down to because I'm explaining this as I go. At least that's the excuse I'm going to use here. I mean, I do sometimes make mistakes like this when programming, but not quite with the frequency that I make when I'm doing this and recording it. Okay, so compare it to 1F. So screenmem A is 2.1. So that's okay. That's okay. All right, so let's see if we ever get to a point where we're either loading that one or that one. We are, and if we look at the PPU viewer, yep, we're right at what is screenmem set to? 1FE0. Oh, okay, so it's it's at the wrong. Yeah, it rolled over. So then, and then it's doing it on the opposite one. All right, so that all seems okay to me. Now the scroll speed is all messed up, and that's affecting the ship and it going off into into the top of the screen. But let's just take a look at this now. And again, remember that the attribute table isn't getting updated when this changeover occurs, so that's why the color of the tiles is wrong. But all right, now it looks like we're actually forcing the update on the tile properly, and we're doing our scrolling. Okay, cool. So that's the part that I wanted to fix for tonight. Let's see if we can get it so that it scrolls at a... Let's see. That's the counter. So if we, let's see, where's process map mode? So that's process map mode. So what's happening right now is that when we do the transition, we are not properly handling this. Let's move this out and make it let's make this part of the main check that we're doing for both modes, because we want to sort of have the same, I want it to transition to the same speed right now. So let's make that work, and then I think I'll call it a night for tonight. There we go. Now the ship is, I think, incrementing up the screen, because if I remember correctly, there's some sort of tie-in to the camera position, and the camera, having looped over, is now totally wrong. But what we might be able to do is take advantage of the camera and use that as our way of timing. So rather than actually using a counter, we could say, okay, well, when we switch over, let's try that before we wrap here. What we can do is we can say, okay, so the camera, if we were going to repeat 5 times, we have 38 by 8 tiles in height, right? So if we were going to do five screens worth of tiles, the camera becomes 1200, which is 4B0 in hex. So let's just set that and see what happens. I think that will stop the ship from doing its weirdness. But that's just going based purely on memory. Sorry, I had to sneeze. That's going based purely on memory, and not on looking at the code. But we'll give that a shot and see if that does anything for us. And if not, then we'll fix this in the next session here. So load A with B0. Stop. B0. Restore that into camera Y position, and then load A what did I say it was? 4. Store that into camera plus camera Y position plus 1. They'll give us 4B0 as our new camera position. This might work. We will see. Could also cause the ship to go a little crazy. So so the ship did jump when we switched over the camera position. I'm almost wondering if we don't even care. This is just the entities. I thought I had something that showed the camera position also. Oh, I do. I just have it commented out. Oh, and then well, we're not decrementing the camera now. Let's move this. This now becomes basically common code here. Because I was using this in the just the map portion, but now we're kind of using that same functionality here, where we decrement scroll Y, load it, compare it, branch not equal to that, load A, EF, store A, and scroll Y, and then. But the only thing that's different at this point is that if we're in process map mode, we want to compare scroll Y to, or we want to look at if scroll Y is a factor of 8 to determine if we want to do yet another update. In this case, we would do done scroll Y, increment, scroll counter. That looks correct to me. Okay. Still not sure if this fixes the problem, but what did it transition back to map mode? It looks like it did. Increment, load, compare. Scroll Y, or it never transitioned properly. Oh, I don't need to do this. All right, you know, instead of trying to kind of mash this all together here, let's leave well enough alone for now. I know this was a short one, but like I said, I'm not feeling great, so you hopefully will appreciate the shorter stream this time. Yeah, so we kind of got it working. It's loading the tiles now. We need to have it properly switch over to loading metatiles, but that's a much simpler problem now that we've got this basic sort of functionality working. Like I said in the previous stream, we're going to start pulling together all of this stuff based on kind of hand stitching it together in the code rather than making the asset tool do that, just because I feel like we're adding complexity that's unnecessary to the asset tool. And like I also said in the middle of the stream, I will work on getting this code synced up to what's in GitLab for those of you who have pre-ordered. But as always, thank you for watching. Sorry that the streaming, the recordings have been less consistent lately. It's just been Mondays have been, for whatever reason, suddenly very busy and giving me problems with recording. So I hope to return back to that once I am back. With that, I would also mention, and I'll put this in the description too, I guess, or the description of the video, and we'll talk about this on Thursday. I will not be streaming next week as I will not be around and available, and the following week probably the same thing. I will be in the Chicago area the following week, so I will not be able to stream. So it's going to be 2 weeks off from, or rather, I won't be able to work on this, and I don't think. So likely 2 weeks of no videos and no streams, but we'll see. And I will remind you as the days go on about that, so you're not looking for the videos or streams. But yeah, thanks for watching, and sorry this is a short, sort of rambly one, but hopefully I'll be fully recovered by the time we get back to it, and I'll see you next time. Thanks for watching. Have a great rest of the week. Take care.